Just a moment. Let me share my screen with you first. Are you getting my screen? Yes.
Yes.
Okay. So let's continue the session. First, I would like to explain what we will cover in this 6 days workshop. So the first 2 days would be the theoretical part of the statistics. In the first 2 days, we will learn about the essentials of the statistics. In these, first we learn various classifications of data. Then we study about the measure of central tendency, why it is required. And then we study about the measure of dispersion. And then we study about the correlation analysis. So this all we cover in our conceptual part, which is the essential of studies in 2 days session, first 2 days. Later on in the third day, we learn about R basics, basic data types, then operators. Then we study about the some syntax, some functions of R. And it will take 2 days. Then we study about the descriptive analysis, with R. Here we study about the univariate analysis and bivariate analysis, not the multivariate. So this we study over here. Is there any query someone has? Yes.
Sir, we cannot do multivariate analysis by our software.
Because no, we can do, but this is not covered in this 6 days workshop. And the later on there is R2. Here we will cover the data visualization and data pre-processing and inferential analysis. Okay. So
Okay.
there it will start with the regression analysis. This all the basically the multivariate analysis, the regression analysis, these all things will cover over there. Okay.
Okay.
So this is the R1. Later the R2 will start later on. So there will cover other topics related to this. Okay.
Okay, sir.
So again come to my PPT. Show you my PPT and here we are going to start this workshop with the data analytics and machine learning with R and Python. Here we are covering only the R. In R, you see we have so many. With R, we have other packages also. For doing this advanced Excel, we could do the data analytics with the advanced Excel. We could do this through the SAS and the SPSS. Okay. So we have the various tools by which we could perform the data analytics. And Python is also there. And for visualization, we have few tools like the Tableau and the Power BI. And for big data filtration, we have the Hadoop. And for the database person, if we see the MySQL and these all things. Uh, Basically, in the data analytics, we perform all 4 types of analysis like the descriptive analysis, inferential analysis, predictive analysis, and the prospective analysis. So in the univariate analysis, data visualization, data manipulation, correlation analysis, this all we could perform through R. And some sentiment analysis, churning analysis, meta analysis. There are so many types of analysis we could perform with few basic algorithm of the predictive modeling, like the linear regression, logistic regression, decision tree, with the help of this. First of all, I would like to explain you what is the difference between statistics, data analytics, and the data science. So, first we see the generic definition of the statistics, as you seen on your screen that uh, statistics is a science and art of collecting, classifying, computing, analyzing, interpreting, and presentation of data and its insights. So, you know that statistics is a science as well as art. And in the statistics, we collect the data, then we classify the data. We have the various classification of the data. Then we compute the statistics. Statistics is what the measure of center tendency, measure of dispersion, other things, whatever we compute in the statistics is called the statistics. And the analyzing the results, whatever the result we get after the computation, we get in some numeric form, and then we analyze it. After analyzing the result, we interpret it in the word in some statement format, and then we present our output in a form of table, in a form of statement, or in a form of graph, whatever, and also the insights of the data. So this is basically statistics perform these or activities. Why it is science? First, I would like to explain you this thing. So look at this a small data I have given shown to you. Can you find out the mean of this data for me? Yes.
6.4.
6.4. Okay. Nice. Hmm. Nice. So I have seen that in the chat box, the most of you have written the 6.4 is the mean of this data. So why most of you are getting the same mean? If someone is not getting any calculation mistake, so we'll get the same mean, because there is some mathematical formula which is working behind this. So it is a science, because we got always the uniform result if we calculate it. So it is a science. If anybody do it and don't make any calculation mistake, we'll get the same result. So it is a science. Because, and second thing, it is an art also. So this is a glass of water. So how do you interpret it? Glass of water. Yes.
Half full of water and half full of air.
Yes.
Half.
Glass is half empty, glass is half filled. Yes. Correct. So most of you have given some interpretation, and I would like to explain here that some of you are telling that there is half filled with water, and some is telling half empty. Statistics shows us so many things in the result, but hide the important one. Okay, so this is the 50% symbol here. Just Sifka, it is the 50%. And the correct interpretation of this glass, the something always hidden behind the value of the result. When you are able to search it out, then you would be a good statistician. So the correct interpretation of this glass of water would be, this glass is full, this glass is full, and half with water and half with air. What, am I right? Because there is air and this is the water. So whenever we get some result, so we have to analyze the result and then we have to interpret it. So the analysis and interpretation required some experience. Okay, so it is an art, because the art always requires some experience. So for interpretation, we require the experience. If we do more and more analysis, you will get the experience and you could better interpret it. So This was all about the statistics. Now we see the next definition, which is the definition of data analysis. So data analysis is a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusion, and supporting decision making. So data analysis is a process. It is not a science and art. It is a process of doing the thing, what we have read in the statistics. First, we inspect the data. Why we inspect the data? Because we see the behavior of each variable in the data. We see how many missing values are there, what are the outliers are there, and then we cleansing the data. We clean the data and we transform the data as per our need. And finally, we model the data with the goal of discovering useful information and informing conclusion and supporting in decision making. So that is the data analysis. So is there any doubt? Any query? Yes? No? Okay. Now the third one is the data science. It is an umbrella term that encompasses data analytics, data mining, machine learning, and several other related disciplines. Okay. Data science is an interdisciplinary field and uses scientific methods, process, algorithm, and system to extract knowledge and insights from many structured and unstructured data. Okay. Data science is related to data mining, machine learning, and big data. So, do you know what is data mining? Can somebody? Yes. So, Aarti, can you explain it? What does it mean?
So, how much I have studied and analyzed,
Mhm.
the data mining would be like we have plenty of data. In that data, we will be like the required data. First, we have to mine, means we have to search for the required data. Then only we can analyze that data.
Correct. Data mining. There are two perspectives of the data mining. One is what you have told. It's right. Uh, we have lots of data and we find out the features which are useful for us. Okay. Second thing, sometimes we don't have any objective. What to do with the data. Correct.
Yes, sir.
And the persons or the company gives us the data. Please, you find out something out of this. Okay. And then also we do the data mining. We
Yes.
find out the useful information out of that data. Correct.
Yes.
There are two perspectives. One is to we have the lots of data, then we have to find out the important data, important variables, whatever. There is important information we have to mine out. Correct.
Yes, sir.
And data analytics, I have explained you, it is a process basically. And machine learning, I will explain you later on when we study about the types of analysis. Here in the last, I have written one thing. If someone has some questions, you could ask me about this. It is recording. Okay, Yafsika, I am recording it. Don't worry. So there is no doubt. Okay. So let's. There is one question in the end of this slide, you see what is first statistics. Can someone explain? Statistics means whatever we calculate in the statistics, mean, mode, median, standard deviation, whatever. Can someone tell me what is the first statistics we calculate? Yes. I think most of you are from the academic line, or you are the scholar and having some knowledge of statistics. Mean is statistics, and data is not a statistics.
Central tendency.
A central tendency is also a measure, but it is not the first statistics. That is statistics, but not a first statistics.
Okay.
I give one hint. You have a categorical data. The column is gender. There is a male, female, transgender. So how do you represent it?
Arrange it in order.
Yes, the one Abid Khan has written right thing, frequency and percentage for categorical, correct. The percentage, the best way to represent the data in a figure or in a table is the percentage for the categorical data. Frequency is not a good measure. Here we take as a statistics. It is just giving us the reflection of how many are there, how frequently the things are going in our data. So that is the frequency we only used in the histogram. Okay, but in the bar plot we use for the categorical data, it would be better to use the percentage instead of frequency. So percentage is what I explain you. When we talk about the percentage, basically it is a proportion multiplied by 100. Okay, percent, that is the percentage. And this proportion is what? This proportion is a probability in statistics. It is the favorable outcome over total outcome. That does that make sense to everyone? Yes. Suppose you have a column gender and there is a male, female and transgender, and we have a frequency of that, and the male we have 40. Suppose we have 80 male and we have 120 female, and we have not 120, I write here 100 and 20 are transgender. If I convert them in proportion or the probability, so what I will get? 80 over 200. Got it? The favorable outcome is 80 and the total outcome is 200. Got it? Anthony, who asked me about this? Why favorable? ML. Got it? So that is the our what we say 2 by 5 is the probability. The first statistic, the statistic starts from the probability. I mean to say, statistics, the seed of statistics is basically the probability. So it starts with the probability. Got it? And also ends with probability. So statistics starts with probability and ends with probability. And between this, everything sustain, like the measure of central density, measure of dispersion, association, everything. So how does it ends with the probability? I explain you. I think that most of you have done the hypothesis testing, the test, you know that the parametric test, T test, G test. How many of you know about it? You know
Yes.
it?
Yes.
So how we how we accept or reject the hypothesis? What criteria we choose for rejection and acceptance? We use the p-value. One of them is the p-value. You know that if your p-value is less than 0.05, it means your null hypothesis is rejected. Got it?
Yes, sir.
So it is the end of your inferential analysis. Got it? Okay. So your inferential analysis, where does it end? It ends with the p-value, is the probability. Got it? Okay. If your p-value is greater than 0.05 at the 95% of confidence level, but at 99% confidence level, it should be 0.01. Okay. So we have a different confidence level. It should be different. If it is greater than 0.05, then our null hypothesis will be accepted. Got it? Got it? Does that make sense to everyone? Similarly,
Yes.
in predictive analysis, it was in the inferential analysis. In the predictive analysis, which is a part of machine learning or the artificial intelligence. So I explain you one. You know that the chatbot, what is chatbot? No, because there are most of the application, mobile application, you see there is a chatbot, and basically in the banking application, banking mobile application, you have seen that chatbot. Okay. So how does this chatbot work? In the chatbot, there are two models. One is the user interface model. Second is the dialog management model. Okay, so we have two models in a chatbot. And what does user interface model do? If you have to ask something in a chatbot, so everybody has a different pattern to write something. Understand? If you have to ask the same information, we will write in a different way. Okay, if the two persons want to ask the same thing, they will write in a different way. Am I right? Yes. So what does an user interface model do? It find out the intention. What is the intention of the statement, what you are writing, and that intent, it will get out the probability. There are so many intent are there in that chatbot. and the entities, so many entities are there in the chatbot, and then it will select, it will find out the probability of different intent. The highest probability intent, it will transfer to the dialect management model. So this intention, so that intention, as per that intent, the dialect management model will respond. Understand? So here, what does it, what is working behind that? The probability. As per the highest probability, it has selected the intent. Got it? So that is the thing. The probability, the statistics also ends with the probability. Okay. In the image classification model also, like a Google Lens and this all, you will see one object and it will give you the responder, that is a bottle or cup or pen. So it also see the probability of the class, which class is the highest probability, and that class it will mention you. Does that make sense to everyone? Yes. Now, I will show you the classification of the analysis. Analysis refers to breaking a whole into a separate components for individual examination. Okay. So we have divided it in 4 components. One is the descriptive, inferential, predictive, and the prospective analysis. So in the first one, the descriptive, you see I have written there the what is. What is means whatever you have in the data at present, it is the descriptive analysis. How many males are there, how many females are there, how many chairs are there, how many tables are there. The range of age of the persons are there, how many persons from 20 to 25, from 25 to 30, and these are all descriptive analysis. Average marks of the student in the section A and the section B and the section C, this is also the descriptive analysis. Standard deviation, I mean the measure of dispersion, measure of central tendency, these are all Tarun, it is our first session today. It starts from today only. Okay. So this is the descriptive analysis. Here we also see the univariate analysis, we see the bivariate analysis, and these all. Second one is the inferential analysis. Why it is? In the inferential analysis, we do some test of the hypothesis. And if we get the significant difference or the significant results in the hypothesis, our null hypothesis has been rejected. Then we see why it is, why this significant difference is there. So inferential analysis is basically a study of cause and effect. Okay, so this is the inferential analysis. And the predictive analysis, what will be? Suppose you have a past data of rain and crop production of a certain region. And you train one model with the past data of 50 years of rain and the crop production. And you would like to predict the crop production of current year. And you know the rain of the current year. Then you put that rain and you find out the prediction for the current year production. Does that make sense to everyone? Yes. Okay. And there is two things. One is the prediction, one is the forecasting. So can someone tell me what is the difference between prediction and forecasting? Yes. One is the prediction, second thing is the forecasting. Yes. Prediction is a predict value, in forecasting we look for the future, correct? Yes. Okay. So what is the difference between forecasting and prediction? I explain you a little bit about it. In the prediction, we require the input, current input. Okay. As I have explained you that we have trained one model for the prediction of the crop production. So we have requirement of the rain of the current year. Then we could predict it. So there is a requirement of current input. Okay. For which you want some sort of prediction. But in forecasting, there is no requirement of the current input. Basically, that is the chronological time order. We get over there. We have to just mention the time and we find out the forecasting for that. Okay. You are also right, Ole Kunel. The prediction can be hypothesis based, and while forecasting can be achieved result based, prediction is more precise than forecasting reality. Correct. Because I will explain you that you are right that the prediction is more precise. Why it is? Because before 5 years in the weather forecasting, there was a. So whenever they predict the weather, they forecast the weather, they forecast that tomorrow would be a sunny day. What we see is there is a rain before 5 to 6 years. And then you say that tomorrow would be a rain, heavy rain, or there is a sunny day. Because they forecast it. Okay. Now what today, we have lots of data through the satellite and these all things. We have the wind speed, we have the so many things, humidity, everything, every data we have. So now they have prepared some model, they have trained some model for the prediction of the forecast, for the prediction of the weather. Now they predict the weather. There is a weather prediction. Previously it was the weather forecasting. Now it is the weather prediction. Now they input the current variables, whatever, the wind speed and everything in the model, and then they find it out, the result. Even before 15 days, they could say the storm will stuck on this coastal area. But it happens. Got it? Am I right?
Sir, once repeat what, according to your point of view, what's for cost?
Okay. Before 5 years, they do the weather forecast. Okay, they have the previous data, and according to that, they make some trend, and a trend line or whatever the trend, and they forecast according to that trend. It will be a rainy day, and it will be a sunny day, whatever. Now they have lots of data through the satellite. They know the wind speed through the instrument. They know the humidity, everything. Okay, and direction of wind, speed of wind. So now they predict it according to that. They put that thing in their model, predictive model, and they find out the prediction. Got it? So prediction are more accurate. Does that make sense to everyone? Yes.
Yes.
So that is the prediction basically. In the prediction for scanning, there is only this difference. In the prediction, we require the current variable input. In the forecasting, we didn't require the current variable input. Okay. And this process is called, the predictive analysis is called the machine learning. Here the machine learning starts. Okay. Whatever we give the data, machine learn it. And then the fourth one is the perspective analysis. What should be? There is the AI comes here in existence, artificial intelligence. So what is the difference between machine learning and artificial intelligence? Both are same thing, but machine learning is an infant and the AI is an adult. A small child, as human being learns the things, we also still we learn, we use some algorithm while learning the things in our day-to-day life. One, we use the supervised learning. So here I am giving the instruction as an instructor. I am giving you some lecture here. So it is the supervised learning. Okay. Sometimes you watch the video on YouTube and Udemy, and there is a semi-supervised learning. Someone is it is the recorded video, and you learn through that. That is a semi-supervised. So there is a supervised, semi-supervised, and the unsupervised learning. Unsupervised learning is what? A small child, there is a utensil of a hot milk. A small child come and touch that utensil. The next time he will touch it or not? Hot utensil of milk he touch, and nobody is giving any attention to him. So next time will he touch or not? He will not touch. That is the unsupervised learning. He is learning by himself. Got it? So this algorithm we use, the reinforcement learning is also there. Reinforcement learning is what? When we give a pen to a small child, and then the most of the child try to keep that pen in his mouth. And then we warn him, or we request him, don't put it in your mouth, it may harm you. Sometimes we beat also. So that is we are correcting the mistake. So that is a reinforcement learning. So this sort of algorithm we use in the machine learning. Supervised, unsupervised, semi-supervised, and the reinforcement. And through this, that infant model, the machine learning model, learn. And after some time, the feed of the ML is data. When we give data more and more, then it would be able to respond to you. When your child gets adult at the age of 16, 17 years, he suggests you. He tried to suggest the parent that please don't purchase this mobile. It doesn't have the good feature. You purchase this one. Now he is intellectual. So similarly, when we give the data in a machine learning model, it converts in AI and it responds to you. So I give one example for that. As we have taken only the one dependent and the one independent variable here, just like a crop production I am talking about. And this crop production depends not only on the rain. There are some other variables also. Rain, then sunlight, then pesticides, seed quality, soil quality, fertilizers, and irrigation. Got it? So rain, sunlight, pesticides, seed quality, soil quality, fertilizers, irrigation, etc. So we feed these all in the machine learning model. These all things. Some are in our control, like the pesticides and the seed quality, which you want the, as per the soil quality, we could use the fertilizers. And the irrigation, as per the sunlight, we could apply the irrigation, frequency of the watering in the field. But rain is not in our control and the sunlight is not in our control. Right? So we put these things and we get some output of that particular region, like X metric ton. But there is a demand of Y metric ton. And you have to fulfill this demand. Or Y is greater than X. So there is a big gap between supply and demand. Okay? And we have to minimize this gap. So then we use this artificial intelligence model will recommend you. It will study the soil quality and everything. And we have the data input there. As per the soil quality of the field, it will suggest you the fertilizers and the seed quality as per the humidity and everything. What seed quality you should acquire there. Every variable input, whatever in our control, will be recommended by this artificial intelligence model, and the quantity of that also. If you apply this on the field, you could minimize this gap of the supply and demand. Does that make sense to everyone? Yes. What is AI? Yes. Okay. So the predictive model is the machine learning, and the perspective, what give you the prospects, what would be the there, and it is a artificial intelligence. So let's we continue our session with the various classifications of the data. Okay. Let's continue with the various classifications of the data. There are various classifications of data, but we will learn about 3 classifications of the data only. One is according to work. Here we see it is only for the numeric one. When we have the numeric data, mostly we get the data in the raw form, raw data, and we convert them in a discrete or continuous form. We discrete and continuous. Raw data is I explain you what does it mean. Suppose we have to conduct a survey in the certain area of a city of 100 families, or different locations for the UNICEF. We have to see how many children below 5 years are there in each family. Because after conducting this survey, we could demand for the polio drops or some other vaccines which could be provided by the UNICEF. So the one surveyor team goes to one colony and they asked 2 things. One is how many children below 5 years, and the children who are below 5 years, they also measure the weight of the children. Okay, so first we see the first our requirement was how many children below 5 years. So we see there is a first family, they got no children below 5 years. In the second family they got 1, third they got 1, then no, then 2, then 1, then 2, then 2, no, 4, 1, 3. In this way they have got the response, number of children. So you see, when we see the unique values, how many unique values are there? Unique values, this is very important term. If we see the unique values, so we got the unique values 0, 1, 2, 3, and 4. At most 4 children were there below 5 years in each family. Does that make sense to everyone? So this is the data of 100 families. And we are getting only 5 unique values out of this. So it is a discrete data. When the unique values are very few, then we convert them, we mention them as a discrete data. Got it? So this is a discrete. Is there any query, any doubt?
No, sir.
Now, second variable what we are doing there, we were measuring the weight of the children below 5 years. For weight, we could get the 10 kg, 10.2 kg, 10.7 kg, 11 kg, 13 kg, 15 kg. In this way, we get it. We get the 100 gram difference also, 50 gram also. So when we see the unique values here, so we see there are unique values out of 80. There may be 60 unique values. There may be 80 unique values. There may be 40 unique values. Does that make sense to everyone? If there are more unique values, then it would be a continuous data. Does that make sense to everyone? Why I am telling you this classification? Because whenever you get the data in Excel sheet or the another database format, you will get only the numbers in one variable. In this way. And this variable, you have to first find out whether it is discrete or continuous. If it is discrete, then you have to convert them in factor. Does that make sense to you? Factor is the data type we will learn in the R. Okay. We will convert that variable in a factor data type. Then further we proceed for the analysis. If it is continuous, then it will remain same. We don't have to make any change in that variable. Basically, both are the numeric. Both data type is a numeric data type in R. I mean, in the R, we convert them in factor, but in Python, we convert them in strings. Got it? So there is a different programming language. I will explain you when we start the R. The day after tomorrow, we start the R. I will explain the data type. So Bangi, you will get better over there. Okay. So that is very important. So we convert them in factor. So this first data type, I already got it. In the continuous data, we keep it as it is. But in manually, what we do in the continuous data, we make the class interval 0 to 10, 10 to 20, 20 to 30 in this way. But here in R, we don't do these all things. Okay. We just keep it as it is. So this was our first classification of the data. And the second classification we see according to nature. Ordinal, nominal, ordinal, interval, and ratio data. Got it? What is nominal data? Wherever you see the naming means suppose we have the city names column. There's a Mumbai, Delhi, and this type. So it is a nominal data. Gender, and whatever the categorical. Got it? It is a nominal data. Second is the ordinal data. Ordinal data is there is an order, but there is no fixed interval. Sometimes we use the Likert type scale there in the ordinal data. We apply the Likert type scale. Got it? And we apply the 3.5, 4.55, 0.6, 0.7 Likert type scale. So I'm giving you an example with a 5-point Likert type scale. So that is a scale I am taking for the agreeness. Strongly disagree, not certain, agree, strongly agree. Got it? And I am giving some number to them. 1, 2, 3, 4, 5. There is this order is there 1, 2, 3, 4, 5, but there is no fixed interval between 1 and 2 and 2 and 3 and 3 and 4. There is no interval. I give one example for this. Suppose there are 3 employees ABC are working in one company on the same post, and the management decided to give them some incentives in the monthly salary. So management decided that 3,000 rupees increment we are going to provide them in the salary. But this small amount, all 3 are strongly disagree with this amount. And then company add on some more amount, rupees 2,000 on the increment. With 2,000, with this 2,000, what happens? I will explain you. Strongly disagree, no certain, strongly agree. Sorry, agree, strongly agree. Here you see Mr. A, from this extra 2,000, he shifted to strongly agree from strongly disagree. But Mr. B, which is 2,000 goes to here, and Mr. C only here. Got it? So there is no fixed interval. Got it? Is there any doubt? In the ordinal scale, ordinal data, not a scale, ordinal data, there is no fixed interval. There is only order. Is there any doubt? No? Okay. So it was the ordinal data. And let me explain you about the interval in the ratio. There is a difference of 0 in the interval in the ratio scale. We have 2 types of 0. One is pseudo, one is real. Pseudo 0, if we talk about the temperature, if I say 0 degrees Celsius, what does it mean? There is no temperature? Does it mean there is no temperature? Okay. If I talk about the marks, if I say the 0 marks, what does it mean? There is no marks. 0 marks means no marks. But 0 degrees Celsius temperature means, it doesn't mean that there is no temperature. There is some temperature. Okay. So this is a pseudo 0. It is not an actual 0. It is not a real 0. So the 0 is some property. Like if you multiply any number with 0, it will convert them in 0. If you divide any number by 0, you get the infinite. Or you divide 0 by any number, you will get 0. These are some property of the real 0. But if you have the 0 degree Celsius and you have to multiply with some value, it will not equal to 0 because it doesn't have that property of the real 0. Does that make sense to everyone? Yes. So whenever we have some data, we see the variable. If there is temperature, there may be some other physical quantities also where we could get the pseudo 0. And we have to see if there is pseudo 0, then what you have to do at this moment. If you have to multiply with this other quantity, then we have two options. If we have very unique values in temperature column, so we convert them in discrete. It is a factor now, or factor means it is a categorical now. Got it? It will treat it as a categorical variable. It will not treat it as a numeric now. Got it? And then we perform with this. Does that make sense to everyone? If we have the very few unique values. If we have lots of unique values in the temperature, then what we'll do? We will convert them in a class interval like this, -15 to -10, -10 to -5, -5 to 0, 0 to 5, and 5 to 10, so on. So here you see, we must keep this 0 in the upper or the lower limit. Sorry, not this 0, this is the 10. The 0 in the upper and the lower limit of your class interval. And then you find out the mid value, which is the class mark. We add on these two and divide by 2. So we get -12.5, we get -7.5, we get -2.5, we get 2.5 and 7.5. Got it? Any doubt? Now we will not get any 0 here. Are you getting any 0 here? Now you could multiply with this any variable. Does that make sense to everyone? So this is very important when you see the data, because we are going to work on the data. We are going to data analysis. So we should know, we should have the knowledge about the data first. What sort of data, what is the nature of the data? So this is the according to nature. No? So this is the ordinal data, nominal data, interval data, and the ratio data. So what is interval data? In interval data, we have both sort of 0, pseudo and real. But in ratio, we have only real 0. Got it? Understand? In interval data, we have both sort of 0, pseudo and real. But in ratio, we have only real 0. Does that make sense to everyone?
Yes.
So only these two are scale. These are not scale. These are the data, nominal data, ordinal data. Somebody says this sort of strongly disagree and disagree Likert scale. It is not a Likert scale. It is a Likert type scale. Got it? It is not a Likert scale. Likert scale is a different thing. I will explain you later on that. Okay. Example of the ratio data, if you have the age of the marks of the student, these are all the ratio data. Got it? Now the third one, according to function. According to function, if you see, this classification we use in the R, there is a numeric, character, logical, raw, and complex. These two we will not discuss about, but these are the technical one. These two. These three we use the data analytics. Numeric, whatever the values you have, the real number, they are all numeric data. We have the integer also. Okay, so these are all numeric data. Character, whenever we write something in quotes in R, like a city name or any person name, whatever, that is a character. Got it? Logical is a binary. Is a true and false. Alphabetical, maybe some number you could write in quotes, it would be a character. It would be treated like a character. If you write anything in a quotes, single or double quote, whatever. Okay. Logical, always you get the response in true and false. Okay, that is a logical. If I assign x is equal to 5, okay, if I ask x is greater than 7, what would be the response of this? If I ask x is greater than 7, what would be the response? False, correct? So it is the binary, logical, sorry. Okay, so that is the logical. So these three types of data we will apply in the our R. Okay, so this was all about the classifications of the data. Because x we have given the Tasi, x we have given the value 5 and we are asking x is greater than 7. X is assigned the values 5 and you are asking x is greater than 7. So what you will respond? True or false? Now we see another topic, that is a measure of central tendency. You know that in every class there is a monitor, and that monitor represents the whole class. Understand? So the same way in the parliamentary constituency, we select one person that is a member of parliament, and he or she represent our constituency in the national level. Got it? Understand? And similar way, we have a data. We could not explain the whole data everywhere. So we require one single value to represent the data. Does that make sense to everyone? Why the center tendency is required? The one value by which we could represent our data. Does that make sense to everyone?
Yes.
So we have three. One is the mean, median, and mode. We have three central tendency. If I talk about the mean, it is an aggregate measure. It is an aggregate measure. Aggregate measure means it involves all the value. Because when you find out the mean, then you will sum up all the value and divide by the total number of values. Does that make sense to everyone?
Yes.
In median, what we do, we partition the data in two parts. First, we arrange the data in ascending or descending order. Later on, we partition the data in the two parts. The middlemost value is called the median. Does that make sense to you? So it is the partition measure. We'll now go to the formula, okay? We just see the utilization of this thing, okay? Merits and demerits, only this thing. Mode is the how frequent the values are there, okay? It represents that the highest frequent value. It is the frequency measure. Got it? So we have three central tendency measure. Aggregate, one is the mean, median, mode. Mean is the aggregate measure, median is the partition measure, and the mode is a frequency measure. Now we see, if I write some data here, we have this data, and I find out the mean of this data, and then I change this value. Instead of 2, this smallest value and the largest value are called extremes. What does it call? Extremes of the data. The minimum and the maximum value are called the extremes of the data. If I change this extreme value, instead of 2, I write 4, less than second value. Here also I could write, instead of 51, 50, I could write the 49, I could write whatever, up to 42. So mean will change or not? Yes, if I change, instead of 2, I write the 4 and then I again measure the mean. Mean will change or remain same? Yes. Will change. So mean is sensitive. It is sensitive to extremes. Does that mean? It is very sensitive to extremes. But what is the mode of this data? Oh, median of this data. Can somebody tell me the median of this data? What is the median? You know that the median is the middlemost value.
50. 15.
15 is the median, correct. This is our median. If I change, instead of 2, I put 4, the median will change or not?
No.
Will median change? No. So median is not sensitive to extremes. Got it? Not sensitive to extremes. Does that make sense to everyone? Similarly, mode is not sensitive to extremes. And mean is always a unique value. No? There is a single mean of every data. Okay. Median would be unique value. It would be only one and only one. But mode may be more than one. Maybe more than one. It may be bimodal, it may be trimodal. Okay. Does that make sense to everyone? Okay.
Yes.
So this is the only about the measure of central tendency. We don't have to go into the formula because the R will calculate each and everything for you. I just want to explain you which thing is why it is sensitive, why it is not sensitive. We will see later on. When we work with the outliers, outliers is always on the extremes of the data. Okay, here. And we impute some value instead of the outlier. And we give some treatment to the outliers. So if your data is normal, then you will believe more on the mean of that data. And it means that again, you have to measure the mean. If you are using somewhere mean of that data, you don't rely on the previous mean because the mean will change when you adjust the outliers. Does that make sense to everyone? Got it? And if the data is skewed, then you will more rely on the median of the data. So there is no need to find out the new median. The median will remain same. Is it clear to all? So when we do the practical, then I will explain these all things, why we have studied these things. Okay. Is there any doubt in this part, measure of central tendency?
No, sir.
Okay. Now we see the measure of dispersion. Can somebody explain me what is dispersion? In one word, can you explain what does it mean by the dispersion? Yes. Variability, spread. Yes. Dispersion from the scatteredness. Correct. Distributing data from mean, deviation. Correct. Correct. You are all correct about that. What does it mean? You know, we have the idea about the dispersion. But when we talk about the dispersion, we have a two type of measurement of the dispersion. One is the spreadness. Second is the scatteredness. What is the spreadness or what is the scatteredness? I will explain to you. I am taking the same data to 7, 15, 16, 20, like this. If I talk about the spreadness of this data, spreadness is between two values. Between two values. This is the spreadness. This is the range of the data. Range of the data is the spreadness. Range is a measure of spreadness. Mean deviation, standard deviation are the measure of scatteredness. Got it? Mean deviation standard deviation are the measure of scatterness. Range, interquartile range, quartile deviation are the measure of spreadness. Does that make sense to everyone? So if I talk about the range of this, not a OD, it is the QD, quartile deviation, semi-interquartile range. Quartile deviation is the semi-interquartile range. Got it? I will explain you later on. If we see the range of this data, range is difference between both extremes, maximum minus minimum. Or if you talk about this, so it is 18 is the range of this data. But if we see the difference between 7 and 2 is 5, here you see 15 minus 7 is 8, here you see 1, here you see 4. So this the scatterness you see here is the scatterness is higher, scatterness between 7 and 15, there is very low. If we see the all scatterness 5 plus 8 plus 1 plus 4 divided by 4, we see how much we get here. 5, 10, 18 divided by 4. 4, 4, 16, 4. 4.5 is the average scatterness of that. If I add 2 plus 4.5, so I will get the next number 6.5. 6.5 plus 4.5, I will get the 11. 11 plus 4.5, I will get the 15.5. Plus 4.5, I will get the 20. Got it? Okay. So it is the average scatterness if we talk about. So it is the 4.5 is the average scatterness of this data. Well, it is not a good measure of the scatterness. They have decided the mean deviation. They have decided that finally they arrived to the standard deviation. I will explain you later on. First we see this range. So I again come to the range and sorry, I take from here. Just a moment. This we have some data and I would like to find out I am picking up two data from here. This is my A data set and this is my B data set. If I find out the range of A, what would be the range of A?
8.
10 minus 2 it is 8. And range of B?
8.
If I give you the only range of A and range of B, can you come to some conclusion? We could not conclude anything if I give only the range of A and the range of B, which is same here. We could not conclude it. Can we conclude it? Nothing. The range is same. So range is a absolute measure. Is a absolute measure. For finding out some conclusion, we required some relative measure. Okay. So for relative measure, we use the coefficients. Okay. We use the coefficients. So we find out the coefficient of range. Coefficient of range is maximum minus minimum over maximum plus minimum. I find the coefficient of range of A, that is 10 minus 2 over 10 plus 2. It is 8 over 12. It is 2 by 3. It is 0.66 or 67, what we could. So the coefficient of range is 0.67. Does that make sense to everyone? Now the coefficient range of B, if I calculate, which is 28 minus 20 or 28 plus 20, which is 8 over 48, which is 1 over 6. So how much it would be? Yes? 1 by 6? Yes. 0.16? Correct?
Yes. Yes, sir.
So it is 0.16. So now you see this coefficient and you see this data. Now you could come to some conclusion. You get some point, some idea. Yes. Anthony, what you are getting through this coefficient of range?
Scatteredness between two variables showing like
If your coefficient is high, then it is from the low value data. Got it? Not the spread. It is not about the spreadness. Spreadness is the same. But this data, the coefficient is higher of the same spreadness data. It means the data is from the low value. And here you see the coefficient is low, 0.16. The data is from the high value data. It represents the high value data. It represents the low value data. Does that make sense to everyone? Is there any doubt?
no, sir. All clear.
So suppose you have got the offer letter from X and Y, two companies, and they just send you the coefficient of range of their employee salary. One company says we have the coefficient of range of the employee salary is 0.45. One says our is 0.32. Which company would you select?
0.32.
0.3. Correct. Why? Hello. Got it? So we get the good salary because the coefficient of the range of the salary is low. It means the high salary they will provide us. Got it? So you got it? What is the importance of the coefficients in a statistics? Okay. Correct. Now, this was all about the range and the coefficient of the range. And second, we see the interquartile range. I change the color. Interquartile range. It is also IQR. Now, if you are getting the data from the outlier side, then it will give the more large coefficient, correct? So IQR is what? It is the interquartile range. We know that we have a data. And here we have the minimum value. Here we have the maximum value. And we have the median here. And this is our third quartile. And this is our first quartile. Interquartile range is IQR is equal to Q3 minus Q1. That is the 50% data you work on. It is called the IQR. Okay. Sometimes what happens, the minimum and the Q1, whatever the data in between, this is called the whisker. And this is also called the upper whisker. When the spreadness in a whisker is higher, the whisker is very longer than this Q3 and Q1 segment, then we work on this IQR. Okay, we rely on this IQR because there is a too much spreadness. Okay, so that is the interquartile range, and there is a coefficient of interquartile range. If I talk about, that is Q3 minus Q1 over Q3 plus Q1. And there is another thing, that is a semi-interquartile range. That is also called the quartile deviation. That is nothing, it is equal to Q3 minus Q1 over 2. And the coefficient would be same. If you divide it by 2, divided the 2 and 2 will eliminate and you will get the same coefficient. Okay. We will see it in the practical. I will explain you with R where we will use it. Okay. This we use for understanding the data and this all. So today we have covered our topic related to the spreadness we have covered today in the dispersion. And tomorrow we cover the scatterness, the mean deviation and the standard deviation and the correlation analysis. And tomorrow itself we will start our R also. And the data types I will explain you with R. Okay. So I will see Mr. Mukesh.
Yes, sir.
Yes, sir. It's over to you, sir.
Yeah. Thank you, sir. So today we are done with the session. I kindly request all the participants make sure that fill up the certificate form if you have paid, and in case those who are not paid, if you're willing to take the certificate or study material, video recording of the session, you can pay rupees 1,000 in Indian currency, or for international participants it is $18. For international participants, we have given the link for PayPal, also a link by pay by credit card, debit card. So try that, and we'll be able to share the details as soon as possible. Today's workshops video and study material will be shared in the Google Drive. It is only for you. Please do not spread it in your community or social media. It is only for you. Those who have paid only will get the link. So thank you very much. Let's meet again tomorrow. We'll meet sharp 5 o'clock tomorrow. All right. Thank you very much.
Okay. Thanks, everyone. Meet you tomorrow.
And those who enjoyed the session can just click on thumbs up button. You have a reaction button on your screen. You just click on thumbs up or clap button for Dr. Parmar. Thank you
Okay.
very much. Thank you very much.
Thanks, everyone. Thanks.